Hey 13 diplomas and welcome back to topic 8 recap. We're looking at strong acid bases in this one. This is part D. Okay, so strong versus weak acids. We know that a strong acid fully dissociates, donating all available H plus ions, and we know a weak acid only partially dissociates, so donating some H plus ions. So if we look here, strong acid, single arrow, and you'll get equal concentrations of H plus and A minus, whatever the acid is. But for a weak acid, you do not. You get mostly it's staying intact as HB, very few H plus and B minus. Remember, you've seen this slide before. You must memorize these strong acids and weak acids and their definitions. Make sure to include fully dissociate or not fully dissociate along with the relevant H plus part. Bit more time this time on weak acids. So remember, weak acids don't fully dissociate. They only donate some available H plus ions. These reactions are in equilibrium. Okay, so most of it remains intact. So if we look at ethanoic acid here plus water, it forms ethanoate ions plus H3O plus. Most of it will actually be this, and there'll be very few of the products. Now this point here is super important. When you have a weak acid or base reacting, so in this case a weak acid, the conjugate base that's produced, which is ethanoate, is also weakly basic, and that's really important. So if we look here, the ammonium ion, which is a conjugate acid from NH3, it's actually acidic, okay? So NH3 plus H2O forms NH3 plus H3O plus, so most of it will remain as NH4 plus, but some of it will dissociate, okay? So NH4 plus is actually a conjugate acid formed from the weak base. Okay, so the only way we can ever get the ammonium ion to be produced is for NH3 to have been reacted prior. So that's something to note, okay? So that's why it's technically not considered a weak acid, because it has to be produced from a weak base, but it is slightly acidic. Okay, monoprotic versus diprotic. This is nice and straightforward. You've seen this before. Monoprotic means one proton gets donated. Diprotic means two. So if you look here, sulfuric acid, when it reacts, actually undergoes two steps, but this is the intermediate step, and so it's never included. People just jump straight from sulfuric acid to sulfate here. So because there's two protons, two waters are required, which means two H3O plus are produced. So if you were comparing sulfuric acid with, say, for instance, HCl of the same concentration, the rate of reaction would be faster, because there'll be more H3O plus produced. So strong versus weak bases. So a strong base fully reacts or dissociates in water, accepting all available protons, or a weak base only partially reacts, accepting some of the protons, okay? So moving on, here's the slide. You've seen it before. You have to memorize your strong and weak. And here are the definitions, making sure you link to H plus ions each time. So weak bases, we'll spend a little bit longer on these. So weak bases only partially react with water, and they accept some of the available H plus ions. These reactions are in equilibrium. If we look at NH3 reacting with water to form NH4 plus plus OH minus, most of it will remain as NH3, okay? This here is an organic base. This is an amine, so methanamine. It will only partially react with water, accepting some protons, so most of it stays as this, okay? Hope that makes sense. Now, please note that the conjugate acids produced from these, so NH4 plus is a conjugate acid, and ammonium, ammonium ion here, these two here, are both weakly acidic, okay? So these are the conjugate acids of your weak base, but they will have some acidic properties. So like ethanoate ions are conjugate bases of your ethanoic acid that we looked at previously. So because this ethanoic acid's a weak acid, ethanoate ions which are produced from it will be weakly basic. So they will partially react with water in equilibrium to produce OH minus ions. Now ethanoate ions are not considered weak bases, but they are weakly basic, and the reason why is because the only way to get ethanoate ions is to actually have produced them by reacting ethanoic acid previously to produce the ethanoate ion. So just bear that in mind, that Oops, sorry, I've just increased the screen again. I don't really know what happened there. That's the only way that you can get ethanoate ions is from reacting ethanoic acid previously. So just to recap on that, weak acids and bases partially dissociate, okay, which means they're all equilibrium reactions and all of them lie to the left, so it's mostly that they stay intact. If you've got a weak acid or base, the conjugate that is produced will also be weakly acidic or basic. And so what that means is that this NH4 plus is a weak acid, so it will react with water to actually produce hydronium ions, and that's really significant. Okay, I hope that makes sense. So I'd like you to pause this and answer these questions. Are the following strong or weak acids or bases? So please pause and I'll go through the answers now. So sodium hydroxide is a strong base. NH3 is a weak base. Methanoic acid is a weak acid. Nitric acid is a strong acid. Hydrochloric acid is a strong acid. Ethanoic acid is a weak acid. Hydrofluoric acid is a weak acid. Hydrobromic acid is a strong acid. KOH is a strong base. Methanamine is a weak base. Okay, concentration versus strength. This is really important not to get this confused. A concentration of an acid or base refers to the amount of H3O plus or OH minus in a given volume, and strength refers to the ease of proton transfer. So often you say someone say like, "Oh, that's a really strong solution," and what they actually mean is it's a highly concentrated solution, because whether something is strong or weak is a predetermined attribute of that substance. So just a little bit of a tidbit. You're not going to be asked on this, but I think it's important to kind of mention it, that even super concentrated solutions may not be very acidic as it seems, because there wouldn't be very many H3O plus ions. And so like concentrated sulfuric acid, 98% of it can actually dissolve in water, which means that only 2% of it is water. So even though it's super concentrated, there are actually very few H3O plus ions in there. Whereas though actually the maximum amount of HCl you can get dissolved is 38%, so 62% of water there. So there'll be much more H3O plus ions in a highly concentrated solution of HCl. So here's some common acids and bases, and we've seen these before. Okay, properties of acids and bases. So the key properties that you could get asked about is the fact about conductivity, so which would conduct better, a strong acid or a weak acid, or a strong base or a weak base. Now we know to conduct electricity in chemistry there has to be free moving charged particles, ions or electrons. The higher the concentration of ions, the better it will conduct. Well, strong acids and bases, they both completely react, and when they react they end up producing ions. So you end up with two ions, both of which would conduct. Cl minus and H3O plus will both conduct. So if you had the same concentration of a strong acid like HCl, so say 1 mole per litre, and the same concentration of a weak acid, so say methanoic acid, well, because methanoic acid only partially reacts and most of it stays intact, yes, you produce two ions, but in a much lower concentration, and therefore the conductivity of the HCl solution would be much higher, because there's a much higher concentration of ions. Just remember, you lose marks if you say only H3O plus conducts. I don't know why kids think that. Both the ions do. So Cl minus would conduct, H3O plus would conduct, methanoate and H3O plus would conduct. Okay, pH, you can compare the pH of the two to see which one's stronger. So if you started with the same concentration of two acids, the one with the lower pH would be the stronger acid. But remember, you can only use pH as a comparison if you're comparing two acids of the same concentration. The final one, rate of a reaction. The higher the concentration of H3O plus, the faster the rate of reaction. So as per above, because a strong acid would produce a higher concentration of H3O plus, the reaction would occur faster. So conductivity, we've said this before, but a strong acid fully dissociates. There'll be more ions compared to that of a weak acid, so it'll be a better conductor. Strong acids react faster than a weak acid of the same concentration because there are more H3O plus particles for the same volume. So here's a task. Please compare the conductivity of a 1 mole solution of HCl with 1 mole ethanoic acid. You could say, we'll say there's 50 mils of each. So which one's going to have better conductivity? Okay. Well, the answer, you know it anyway, but to conduct electricity, there must be free moving charged particles, e.g. ions. The higher the concentration of ions, the better the solution is at conducting. Here's your HCl concentration equation, a single arrow. It completely dissociates. So if you start with 1 mole per litre, then you'll end up with 1 mole per litre of H2O plus and 1 mole per litre of Cl minus. As both products are ions, there'll be a lot of ions available to carry charge. Ethanoic acid, weak acid, in equilibrium. If you have 1 mole of ethanoic acid, very little will dissociate, so there'll be less than 1 mole per litre of ethanoate ions and hydronium ions, so there'll be very few ions to carry a charge. Okay, compare the rate of reaction, the same volume of 1 mole per litre HCl with 1 mole per litre ethanoic acid with magnesium. So here are the two equations, okay? Now these are actually both one-way reactions because we're not reacting in water here, we're actually reacting with a substance and they both will fully react. It's just the fact that because HCl fully dissociates, it reacts faster, okay? So HCl has a faster rate of reaction as it is a strong acid, so completely dissociates, meaning all the H3O plus particles are available at the beginning of the reaction. Because remember, rate of reaction, we're always concerned about that beginning bit. When the magnesium's disappeared, 10 centimetre cubed of gas was produced. I'm going to talk about this in a second. Ethanoic acid has a slower rate of reaction as it's a weak acid, so only partially dissociates, meaning there are few H3O plus particles available at the beginning of the reaction. Okay, when the magnesium disappeared, there was 10 centimetres cubed of gas. So the key thing here is the fact that because HCl is a strong acid, it'll immediately dissociate. So loads of H2O plus particles available at the beginning, and therefore the initial rate of reaction is faster than the weak acid. However, hopefully you're seeing that both of them produce the same volume of this gas, and that's because both of these reactions actually go to completion. And the reason why is because as that ethanoic acid reacts, what happens is, oh sorry, that should be a minus, that's a wee typo. As this reaction proceeds, the ethanoic acid reacts with the magnesium and it produces these ethanoate ions and H3O plus ions. Now, as these H3O plus ions are what react with the magnesium, continuously in this equilibrium, you are removing the H3O plus ions. And if you're constantly removing the H3O plus ions, the equilibrium is going to shift to increase the concentration of H2O plus ions, and it's going to do that by shifting the equilibrium to the right, which causes more of the ethanoic acid to dissociate. So that's why all of the acid ends up reacting, because of this equilibrium, and because the H2O plus react with the magnesium, it removes them from this equilibrium, making the equilibrium make more until there's eventually no more ethanoic acid or no more magnesium. So I hope that makes sense. And so because they started with the same concentration of this in HCl, which means the same amount of protons available, they'll produce the same volume of H2 gas. Here's some important definitions to make sure that you can actually define these, okay? A key thing is that you've got to talk about completely dissociating and the ions every time, okay? Conjugate pair, differ by an H plus ion. We haven't looked at that for a while. Acidic solution, you can't just say H3O plus. You've got to say a greater concentration of H3O plus than OH minus. A basic solution, a greater concentration of OH minus than H3O plus. And pH is a measure of H3O plus in solution. Okay, team, I'm going to leave it there and come back and do a part E. See you soon.